In this video, I will talk about how to run a chi-square test using Excel. In general, there are two types of chi-square test. For chi-square goodness of fit test, it is used when you want to see if observed frequencies of a single categorical variable fit an expected distribution. For example, testing if a die or a coin is fair. For chi-square test of independence, it is used when you want to see if there is an association between two variables in a contingency table. For example, investigating if there is a relationship between gender and voting preference. First, let's look at goodness of fit test. A researcher wants to determine if a six-sided die is fair. To test this, the researcher rolls the die 60 times and records the outcomes. Using a chi-square goodness of fit test, determine whether the die is fair at a significance level of 0.05. For the null hypothesis, it will be saying that the die is fair. Or in other words, it follows the expected distribution. For alternative hypothesis, it will be the opposite. As you can see, in these 60 rolls, face 1 showed up 7 times, face 2 showed up 8 times, and so on. If the die is fair, then the number of times each face showed up will be the same. That should be 60 divided by 6, which is 10. In Excel, there is a useful function called CHISQ.TEST, which can be used to compute the p-value directly. The first parameter will be the observed frequencies, and the second will be the expected frequencies. Here, the p-value represents this upper tail area. Since it is less than 0.05, we reject the null hypothesis. The die is not fair. Next, we move on to the test of independence. Here is the question. A researcher wants to investigate whether there is an association between students' study habits, study late versus study early, and their performance on a test, pass versus fail. Data is collected from a sample of 100 students. Using a chi-square test of independence, determine if there is a significant association between study habits and test performance at a significance level of 0.05. The null hypothesis will be saying that two variables are independent, while the alternative hypothesis will be saying that they are dependent. The observed data is summarized in this contingency table. Assume two variables are independent. We need to compute the expected frequencies for each cell using this formula. For students who study late and pass, the row total is 40 while the column total is 53. For students who study late and fail, the row total is 40 while the column total is 47. For students who study early and pass, the row total is 60 while the column total is 53. For students who study early and fail, the row total is 60 while the column total is 47. After computing all the expected frequencies, we use the same function to get the p-value. The first parameter will be the observed frequencies, and the second will be the expected frequencies. Here, the p-value represents this upper-tailed area. Since the p-value is less than 0.05, we reject the null hypothesis. Study habits and test performance are dependent. Based on the sample data, the pass rate of students who study early is higher than those who study late. That's how you run a chi-square test using Excel. I hope it helps. See you next time.